Hi everyone, welcome to Matrix Uploaded. My name is Nelson. In this segment, guys, we're gonna talk of the basic laws of exponents. In the previous lessons we did, but we didn't cover all the basics. Now let's look at the entire exponential laws. Okay, we have this. We're talking of the basics here. A to m times a to n. What do you see? Same basis at the top. We did. A to m plus n. Okay. Numerical, or just example, not yet on the numerical. Numericals are on the exponents. But look, x to 4 times x to exponent 1. Where do we go? At the top as well, because the bases are the same, exactly the same, then x to 5. You're happy with this? I know, guys, you love this stuff. Multiplication again, 3 plus 3 will give you 2 to 6. Now, this is purely a numerical example. Evaluate it. We may not be able to evaluate this one, x to 5, but 2 to 6 can be evaluated to 64. Happy? Now let's get to the next example of the loss. A to m divided by a to n. Division, I applied this in the previous lesson. Then we have m minus n. Subtract your exponents. Let's see the example now. You dividing, go 4 minus 1, we have 3. Happy? Now, again, same basis, 12 minus 10 is 2. Then we have 4, 2 squared, which is 4. Okay, this, a power of a power, we call this power of a power. You simply multiply the tops. Guys, don't confuse this with the first law. This you have one base, and then the exponents multiply each other there. Then you have m times n, which is a to mn. Now, the example supporting this rule here, or this law here, if you're having something like this one needs a share as well. Most of you guys, you tend to forget this coefficient. Your answer will be 3x to 8, of which is wrong. This is inside the brackets. Whatever you do here, you must also do there. Okay, 3 squared, and then x to 4 squared as well. What do you have? 9x to 8 is that answer that you have there. Okay, that 9 comes from there. This law here, x to negative n. Remember, your negative, you take the whole power to the bottom. What happens? You can't just take it to the bottom, change the sign from negative to positive. Cool. Let's look at the numerical example. Yes, I took it as 1 over 3 squared, which is 1 over 9. You happy with this rule? I'm quite sure, guys. Now, we get into the reverse of the law that I was talking about. 1 over x to negative exponent. The same thing. Take it up. What do you do? Change the exponent. We still apply the same thing. Okay, when you don't have a fraction, make it a fraction. You take it to the bottom. You have a fraction already, back up. Look. Now, you have this. I take it up. This is actually 1 times that. I know that 1 is not going to affect that. This is why I went straight away, x to n. Can we get the numerical example? Yes. Take this up, then you have 9. Cool. We have this law again, which says a to 0 is equal to 1. This one we know. I'm not going to talk about this. You're happy with this, guys, I know. Example, anything raised to exponent 0 is 1. Don't make it 0 is 1. You know that. Now, let's have a look at this challenge. X to 0 is the only one that takes 1. Then 5 stays as 5. It's not 1. The whole thing's not 1. Only this part here. So you have 5. 5 times 1, which is 5. Okay, let's look at some examples where we simplify. Simplify this. Apply those laws of exponents. Guys, as I said, this one goes there. Don't forget your number. This number, guys, needs a share as well. Needs a share. And then you have this as well. This will become 9x to 8 plus 16x to 8. The same thing. What you did there, you do here. Do you see like terms? X to exponent 8 and x to exponent 8. Like terms, yes. Add 16 to 9. 25, x to 8. Let's look at another example. Multiplication. With multiplication, do not forget to multiply your numbers as well. What is that? 3 times 3 is 9. And then here, should I go 5 times 5? No. The bases are the same. Remember the law, as this was our first law. Just add 5 plus 5, which is 10. 9x to 10. Cool. Now we're having more advanced sums, but still applying the same laws. We still stick to the laws, guys, but more advanced sum, bit by bit, gradually, until we get to the answer. Let's look at the sum. So I can add the inside if I want. Here I can multiply. This is not x to 6 because this means plus, like terms. This way you're collecting like terms. Then you can have 2 of them, of this. And then here you multiply, as it says multiplication. Then you add now, 3 plus 3 is 6. Don't confuse the rules. Then do your sharing part. So you have this. Firstly here, what I did here, I divided x cubed by x to 6. I got that. Okay, what I got is this. And now I multiply. Now I multiply my exponents, but sharing part, don't forget, this 2 gets 3 as well. 2 cubed is 8. Now negative 3 times 3 is negative 9. Always we need writing as positive exponents. If you leave it here, we can't say it's fine, guys. We're happy if our guys learn how to write this as positive exponents. Now, remember the rule, what do we do? It's not a fraction, take it to the bottom. Now it becomes 8 over x to 9. Okay, I just did an example where we have so many laws applying in a specific sum. Okay, guys, remember your laws, stick to them, just write them somewhere, keep on referring to your laws each time you have exponential sum. See you in the next segment.